You've learned quite a bit about systems of equation, specifically how to solve when graphing. Now we're going to look at a new method called substitution. Specifically, we're going to look at using substitution when both equations are already written in slope-intercept form. We will continue our topic of substitution next week with some more complicated examples, but we wanted you to at least have an introduction this week as well. So I've written out the steps for you and they're included in your notes as well, but we're going to use this method today when both equations are in slope-intercept form because you can easily use substitution by putting one value of y equal to the other value of y. Then you use inverse operations to solve for x, and once you have the value for x, you plug that back into either of the two original equations to find the value of y. So your final solution is written as a point or an ordered pair. Just how when you did the graphing method, you noticed that the solution was the point where the two lines intersected. Lastly, we're going to check our answers by plugging the x and y value into both equations to make sure they are true. So we're going to do at least 3 examples together, and then you'll be able to do a few of your own on the following assignment. So in this first example, y equals 3x plus 1 and y equals 2x minus 3. Both of these equations are already in slope-intercept form because both of them are y equals. So what I'm going to do now is I'm going to set them equal to each other. So I'm going to take this 3x plus 1 and I'm going to set it equal to this 2x minus 3 because both of those are equal to y. So now I have an equation with only one variable. And step 2 says I'm going to use inverse operations to solve for x. So let's do that together right now. So 3x plus 1 is on the left side and 2x minus 3 is on the right side. So whenever I have an equation with variables on both sides, my goal is to move all the variables to one side and try to isolate that x. So I'm going to do that by first subtracting 2x from both sides. When I subtract 2x from the right side of my equation, it cancels out. And when I subtract 2x from the left side, 3x minus 2x is just 1x, or x. So then I have x plus 1 equals negative 3. Now I'm going to subtract 1 from both sides. Negative 3 minus 1 is negative 4. So I found the value for x. Step 3 says once you have the value for x, plug it into either of the two original equations to find the value of y. And it doesn't matter which one you choose. I'm going to go ahead and just choose the first one. Y equals 3x plus 1. But since I found the value of x, I'm going to plug that in. So that's 3 times negative 4 plus 1. Positive 3 times negative 4 is negative 12, and negative 12 plus 1 is negative 11. So that means the y part of my solution should be negative 11. So if I write my solution as an ordered pair, it's negative 4, that's the x, and negative 11, that's the y. But now I need to check it using both of my equations to make sure they're true. So let's first check with the first equation. Y equals 3x plus 1. So we got negative 11 for y equals 3x plus 1. So that's 3 times negative 4 plus 1. That's negative 12 plus 1, which is negative 11. So negative 11 does equal negative 11. Now let's check using the second equation. Y equals 2x minus 3. I'm going to take the y part of the solution that I got, which was the negative 11, and I'm going to replace the y with it. And then I'm going to replace the x with negative 4. And I get negative 11 equals negative 8 minus 3. And negative 8 minus 3 is negative 11. So since it checked on both of my equations, I'm going to feel confident in knowing that I got the right solution to this system of equations. So the solution written as an ordered pair would be negative 4, comma, negative 11. Let's go ahead and do another example. All right, so this time we have y equals 5x minus 7 and y equals negative 1.5x plus 6. So again, both of these equations are slope-intercept form, or y equals. And since they're both y equals, I'm going to go ahead and set them equal to each other. So on the left side, I'm going to write 5x minus 7. That came from the first equation. And then the second one, I'm going to go ahead and replace, because I'm allowed to say y equals y. They're the same thing. So that's why I'm able to use substitution and replace the y with what it's equal to. So then on the right side, I've got negative 1.5x plus 6. Okay, step 2, use inverse operations to solve for x. So now I'm just rewriting it here because I have a little bit more space to show my work. All right, remember, whatever you do to one side, you must do it to the other side as well in an equation. All right, so I'm going to try to move the x's to the left side of the equal sign. So I'm going to begin by adding 1.5x to both sides. Adding 1.5x to this right side, it cancels out. Adding it to the left side, I get 6.5x. And then I have that minus 7, and then I have equals positive 6. Now I'm going to go ahead and add 7 to both sides. This one cancels, and then on the right side, I'm left with 13. So now I have 6.5x equals 13. My last step in solving for x would be to divide both sides by 6.5, or 6.5. 6.5 divided by 6.5 is just 1x, and 13 divided by 6.5 is 2. So I got x is equal to 2. That's only half of the solution. Now I need to figure out the value of y. So I'm going to use that first equation. Y equals 5x minus 7. And I'm going to substitute the x with the value that I just calculated, which is 2. So I get y equals 5 times 2 minus 7. 5 times 2 is 10, and 10 minus 7 is 3. So I believe y is equal to 3, but I haven't checked my work yet. So I got x equals 2 and y equals 3. But remember, the solution to a system of equations is a point. So I need to write that solution as an ordered pair. So I'm going to write it as 2, 3. And now I'm going to check my answer by plugging it back into both equations. 3 equals 5 times 2, which is 10, minus 7. So that one works, which we were pretty sure that one would work since that's the equation that we used to find y. The true test will be if it works for my second equation. All right, so my second equation is y equals negative 1.5x plus 6. So I'm going to replace the y with 3, and then I'm going to multiply negative 1.5 times 2, and then add 6. Negative 1.5 times 2 is negative 3, and negative 3 plus 6 is positive 3. So that one also checks out. So since both of these checked, I can feel confident in knowing the solution to my system of equations is 2, 3. I'm trying to highlight it here. Let's do one more example together to help you feel confident with substitution. All right, example C. Y equals negative x plus 3. So once again, this one is in slope-intercept form. The second one is y equals negative 3x minus 3. Since they're both written as y equals or slope-intercept form, I can set the right sides equal to each other. So on the left side, I'm going to write negative x plus 3. And then on the right side of the equal sign is equal to negative 3x minus 3. So now I have an equation with only one variable, which is x. So I will use inverse operations to solve for x. So I'm going to try to move the x's to one side. I'm going to go ahead and, because I don't like to deal with negative numbers unless I have to, it really doesn't matter which one you try to move, but I'm going to go ahead and add 3x to both sides. And remember, I'm adding the 3x because this is a negative 1 here. So that canceled out. Negative 1x plus 3x is positive 2x. So then I have 2x plus 3 equals negative 3. Then I'm going to subtract 3 from both sides. This one cancels out or becomes 0. And then on the right side, I have negative 3 minus 3, which is negative 6. So I have 2x equals negative 6. My last step in isolating that x would be to divide both sides by 2. That's a positive 2, not a negative 2. 2 divided by 2 is 1, and negative 6 divided by positive 2 is negative 3. So I believe the first half of my solution is x equals negative 3. All right, now that we have the value for x, we can plug it into either of our two original equations to find the value of y. I'm going to this time plug it into the second equation, just for the heck of it. Y equals negative 3. Instead of saying times x, I'm going to plug in that value, which is negative 3 minus 3. Negative 3 times negative 3, they're both negative, so that's going to give me a positive 9, and 9 minus 3 is 6. So I believe the second half of my solution, or the y-coordinate, would be 6. So I'm hoping that my solution is negative 3, 6. But of course, I'm going to check my work. Let's plug it into the first equation to see if it makes a true statement. Y equals negative x plus 3. So now I'm going to write 6 equals negative x, which x is negative 3, plus 3. So because I have another negative symbol on the outside, it's like saying the opposite of negative 3, which is a positive 3. And positive 3 plus positive 3 is positive 6. So that one definitely checked out. Now I'm going to check it with the second equation. 6 equals negative 3 times x, which is negative 3, minus 3. A negative 3 times a negative 3 is a positive 9, and a positive 9 minus a 3 is 6. So this one also checks because 6 equals 6. So I checked it using both equations, which means that the work that I did was correct, and the solution to this system of equations is negative 3, positive 6.